Hello and welcome to this lesson on the fragment component and class in Android. In this and following lessons, we'll cover the capabilities and usage of fragments in your applications, and how they can enable us to create better designed components for applications designed to run on devices ranging from small smartphones to large tablets. The fragment class was first introduced in Android API Level 11, which correlates to Android 3.0.x, or the Honeycomb release of Android. This was the Android version released in order to enable Android to run on tablet devices. One of the goals of the Fragment class was to help design UI with components that could be reused in different parts of an application's interface. Meaning if we had the same component that we would need to take up the left half of a screen on a tablet and the whole screen on a phone, then we could design that component as a fragment so it could be reused easily for both the tablet and phone requirements. Although fragments were released with Android 3.0.x, there's an implementation of Android Support v4 App Fragment that allows for fragment backwards compatibility for designing applications with fragments for Android APIs prior to Honeycomb. This backwards compatibility class is available through the Android Support library. Fragments are meant to be a complete UI and logical package for the specific component they are implementing, so they have their own UI and life cycles to manage. As described via the Android developer blog, in some ways you can think of a fragment as a mini activity, though it can't run independently but must be hosted within an actual activity. Fragments are embedded within a host activity. These host activities can contain one or more fragments and will ultimately be responsible for managing the fragments through things like lifecycle changes and requests for presenting views. Allowing for easier plug and play and usable capabilities, fragments can conveniently be added to layouts for activities through the Activities Layout XML. Since there is more screen real estate in a tablet than in a phone, the design of each screen may be affected, in particular the amount of components that can be fit on one screen. In the example seen here, we have two fragments, Fragment A and Fragment B. Each fragment has a desired UI that should be presented to the user. While displaying Fragment A alongside Fragment B in a tablet offers a comfortable user interface for the user, displaying them alongside each other on a phone would be crowded and counterproductive. For that reason, we are able to design an application that when used on a tablet displays the two UI components for Fragment A and Fragment B side by side, and when run on a phone device displays the first Fragment A, and then after a user interaction opens a new activity with Fragment B. One of the common implementations of fragments in Android applications comes in conjunction with the view pager element. A view pager will allow a user to swipe horizontally in order to page through several different views. Fragments offer a useful and effective tool for displaying each page inside the view pager. This allows us to easily separate the logic and the UI for each page in the view pager to its own separate fragment. Thank you for joining us in this introduction to the fragment component in Android. Join us in our next lesson where we further cover building applications for multiple devices.